Oh, good morning. Good morning once again. Welcome to our pre-lab lecture. Today, we are going to look at uh, lab on physical and chemical properties of element. I'm sure you have covered these in the lectures portion of the course. Uh, this is a dry lab in the sense that you don't have to do the real experiment where you have to mix reagent. You have to just look at the video clips. There are a couple of video clips I posted on announcement, which you need to watch them and fill in the data sheet. However, I want to walk you through a little bit of what it's all about in terms of each section. In case you did not, let me share my screen first before I walk you through the experiment, how to complete the data sheet and what you need to do for each section. This is the data sheet on, all right? In the announcement section, this is where you will go to watch the video clip. Under the announcement, the day is physical and chemical properties, and it's just up here, physical and chemical properties. You click on the announcement. I do have several video clips for each section. If you look at part A, instructor demonstration, what you need to do in number one, number two, number three, and so forth. On the data sheet, you will skip those I've marked as a skip. You will see on the data sheet part C1, and I think in part D as well. You'll have to skip some section. For example, this skip this. You gotta skip this on the data sheet. I'm gonna show you that. So the main point is, where do you need to go in order to watch the demonstration for each section? You have to access the videos on announcement. It's under the announcement tab on Canvas, and then you will go to assignment to download the data sheet. To download the data sheet, let me at the bottom of the page. If you don't have the handout yet, it is at the bottom of the page on the announcement right here. It's a little tiny. Maybe you missed it, but this is where you need to download the handout. Alternatively, you can go to the respective module on today's experiment. So let me just download this and see what we need to do today. Explain to you what you need to do as far as this lab is concerned. All right. So physical and chemical properties. These are the objective, except the last one here. I don't think you'll be able to demonstrate or watch a video on boiling point. You will skip this section. You will not see on the data sheet. However, the objective is to see oxidation of copper. In this case, as far as oxidation, is just burning, all right, combining oxygen with an element. And in this case, you will observe the reaction of copper metal with oxygen. We call that oxidation. And then observe sublimation. Sublimation is the change of state of solid from solid to gas without going through the solid state. Remember, there are six of them. You will observe the sublimation. There is melting, there is evaporation, there is deposition, and also, but there is only one sublimation. You'll also look at the appearance of, several elements on the periodic table. On this one, all right, on this one, observing the elements, you will be able to look at the periodic table. There was a periodic table. Let me see, where is the periodic table? Should have the periodic table of elements. I'll double check, make sure you have right here, periodic table. What I want you to do on observing, say for example, hydrogen, based on how you react, you will see the appearance, there are so many information, but the much you can get from the interactive periodic table I posted online, you will fill in the color, all right? The using the periodic table, solid, liquid, or gas, you can complete the chart on right here. Let me just show you. Somebody was in here. This is where you will have to fill in terms of the appearance, If you look at the cobalt, I'm just gonna go to cobalt. What is the physical, what is the chemical symbol, physical state, color? If you don't see on the interactive periodic table, just leave it blank, all right? Put it dash. If you don't see on the periodic table, the description, all right? And then of course, I know you can classify an element as either metal, metalloid, or semi-metal, and the non-metal. That's what you need to indicate. Not everything on the periodic table, all right? All what you have to do here is just go to the periodic table, and you will zoom into each of the elements. It's gonna give you information, all right? If I click here, you will see appearance, all right, gray in terms of color and so forth. And of course, you can use the periodic table to state whether it is solid, liquid, or gas, solid, liquid, or gas. That's the demonstration or appearance, so the appearance of several elements. And then determine the boiling point. You're not gonna do this. Determine whether it is soluble or insoluble. You have to observe. You have to observe the demonstration to tell whether it is soluble or insoluble. Some of the clip might have, unnecessary information. Just pay attention that I'm looking forward solubility of a given substance in H2O, and then say it's soluble. The video clip might give you more information than what you need to respond, all right? You'll determine whether the substance has a physical change or a chemical change. Let me just briefly show you what is, all right, the changes, so that when you get in there, you'll be able to identify solid change. We have here physical change, all right? There is a physical change here. And then there is a chemical change. Chemical change. How will I know, whether a change is physical or chemical? Assume you have a substance A, for example. Let's just pick an arbitrary substance A going to A star, all right? You have to classify a change here as chemical or physical. Here, physical change versus chemical change, all right? Physical change versus chemical change. In chemical change, chemical makeup or composition of matter is not altered, all right? It's not changed. Or you can also look at this as reversible, all right? That means you can reverse, that is for physical change. Those are the key things you need to look at. Is it reversible? If it is reversible, and then you consider that or classify that change as physical. If you don't change the chemical makeup of a substance, then you know that is physical change. Before we look at the chemical change, let me just give you examples of physical change. Here, examples include uh, melting. There are 6 of them. Melting, there is freezing, all right, coming back to solid from liquid. There is vaporization, all right. There is the condensation, sublimation. There is deposition, all right. You know this from lecture, deposition. These are examples of physical changes. We also have the solution. That means dissolving, all right. When you something dissolve, you may think that some chemical change has taken place. No, if you think about dissolving sodium chloride, the table salt. If you dissolve, you can get back your table salt. If you evaporate H2O, then you get back. It is reversible. All right. There is the grinding or shredding. That is, you don't change the chemical makeup. All right. That is what you need to look at in physical change. Then there is chemical change here. This chemical change. This is, in this one, chemical, you have to look at this, chemical makeup of a substance, all right? Substance is altered, all right? You change the chemical makeup. This is irreversible. That means once it happens, you will never get back your substance, all right? Once it happens, you'll never get back your substance. Once it happens, you'll never get back your substance. This includes, all right, examples include combustion. That means burning, when something burns. All right, it includes digestion, right? Digest. If you digest food, you know it is irreversible, right? Rusting, all right. Those are just few examples of chemical change. This is accompanied by, all right. Chemical change is accompanied by chemical reaction. Chemical reaction. How will I know that a chemical change has taken place? If there is a chemical reaction. And evidence of a chemical divide. We call evidence of a chemical reaction, evidence of a chemical reaction, you know, from the lecture. There are what? Let me just go to the next page here. Evidence of chemical reaction is permanent what? Permanent change, permanent color change. Cars is produced, that is bubbling. 3 here, precipitate is formed, all right, is formed. That means solid. If a solid is formed, then you know chemical reaction take place, and you classify change as chemical in this case. So I'm just going to be looking at this, including here heat. You may not be able to do this, but just for your own knowledge, heat is generated, heat is evolved, all right? If heat is given of exothermic, if light is given of, you know, these are, you know, a chemical change has taken place. So for here, just, you know, you can get this more on the changes, so that at least you're gonna be able to classify. If you look at here, you may not be able to, here, chemical, you have to see chemical reaction. How will I know that chemical reaction has taken place? Is by paying attention to the 4 evidences I've just given you. Facing, that means gas is given up, all right? If there is a permanent color change, formation of insoluble solid, all these I know you are familiar. Other than that, you know, there are more information on the handout. We're not gonna do all this, but for the part A, part B, all this, don't worry about, you know, reading this and trying to answer the question or fill in the data sheet. All you have to do is say, for example, hitting of iodine crystal, you'll go to the iodine crystal, for example, right here, you see iodine crystal. You will just have to watch the demo, all right?
This is elemental iodine, the dark black bluish solid at room temperature. Iodine is the heaviest of stable halogens. When we heat up the iodine, it's going to turn directly from a solid into a gas. The iodine vapor has a beautiful purplish color. This process is called sublimation, turning directly from a solid to a gas. Then we place a cold flask over top of the vapor. The warm vapor will cool off on the cold glass, and the gas will turn directly into a solid. This process is called deposition. In this case, we're seeing the deposition of iodine onto the cold glass surface, where we would say that iodine is deposited onto the cold glass.
So that is that's just one demonstration on what you need to do for each. If you look at the copper crystal solubility, you'll have to write that and complete the data sheet. Here is the data sheet. So if I was to complete for iodine, all right, sublimation, all right, where was the sublimation for? Was it up here? Just to look at, yeah. Heating of iodine crystal. You see here, iodine crystals, observation, what will you observe? And then here, based on what you will read, all right, you will classify the change as either physical or chemical, either physical or chemical. You do the same thing for copper wire, and where I've indicated XX or skip on the data sheet, you don't have to do anything on that. You don't have to do, like, for example, this one, skip, all right? This one I see there is a skip, and yeah, this one I think 2 of them you have to skip. Other than that, that's all what I want you to do. Remember to access the video demonstration. They are all posted on the announcement section for this lab. I have the data sheet posted under the assignment with the respective folder for this experiment, where you'll have to go in there and fill. You can download and use your pen to fill in. If you're comfortable typing it in, that's fine. You'll have to submit just as usual through Canvas. Don't send as email attachment. Don't send as email attachment. Other than that, the quiz for this lab will be available by end of the day, due by end of the day, due Wednesday. Remember that the semester is going pretty fast. If you think about it, we just started the other day, yet it's ending in 2 weeks. So stay on top of the game, do your work, submit on time, and all will be good. Other than that, if there is no question, I will stop sharing the screen. You can use the chat feature to ask any question you have, and I'll respond before I end the pre-lab lecture. Is there any question for as far as today's lab is concerned? Is there any question? You can use the chat feature if you have any question. If there is no question, I will stop. Thank you, Jerry. Thank you. I'll stop sharing the screen. The class is, this means please stay safe, sanitize, and stay healthy. Thank you. The class is dismissed. See you on Wednesday. Remember to check the announcement, your email on when the quiz will be available and more information. Otherwise, be safe. Have a good morning.